In this chapter, we're going to talk a little bit about graphing and some of the advanced things that you commonly want to be able to do, but are somewhat annoying to do. In this case, there's a bunch of things that we're going to want to be able to do. So first off, one of the things that we want to be able to do is to make a graph that actually is multiple figures all at once. Now we've sort of done this before using ggplot's facet wrap and facet grid, but that requires making a grid of graphs that all have the same format. So either it's a bunch of scatter plots or it's a bunch of bar charts, but they're the same chart repeated over and over and over for different factor levels. What we want to do now is generate something that allows us complete flexibility to be able to say, well, I want a graph like this. This is going to be subfigure A. This is going to be figure B, C, D, and I want complete control over what those are. All right, so that's what we're going to do. Now, there's two ways to do this. First off, we're going to talk about this function from the cowplot package. Now, the cow part doesn't actually refer to a cow. It is the initials of the author, Klaus O. Wilkie, C-O-W. And he wrote a very nice book, where I've got a link to the book, about data visualization and R, and he's got a nice R package to help him tweak his plots. So that's called cowplot, and there's a function inside there called plot grid, which takes a bunch of plots and then just lays them out on a grid. So here I'm going to define plot 1, plot 2, plot 3, plot 4, and these are just, they could be base plots, they could be anything, but I've got these set up as ggplots. And they're all very different ggplots. They don't have anything that is necessarily the same about them. And all we're going to do is call this cowplot plot underscore grid function P1, P2, P3, P4. And what it does is it'll generate P1, P2, P3, P4. Now, so these are by default arranged in a 2x2 grid, but I can adjust that as much as I want. So in this case, I'm going to set this up as a 3-panel plot, and I'm going to do plot 2, 3, and 4. I'm going to specify that the number of rows is 1, and so this forces us to have 3 columns. And then we're going to add some labels so that I could call this figure A, figure B, figure C. And this is the sort of plot that you would expect to see in a scientific article or something like that, where we've got sort of 3 subplots. Now, by default, we gave the same amount of space for figure A as we did for figure B, and that's what cowplot does. If I want something more specific, I have to move to another function. All right. There's a book out there called Our Graphics Cookbook by Winston Chang, he's amazing. He's awesome. Inside that book, he gave a function, but he just gave the code. He didn't release it digitally or in a package or anything like that. And so it used to be that I would, go copy that code and add it to my own project. But fortunately, the folks at the R miscellaneous package, which is this R miss, they included his function. And so I always go to this R miscellaneous package now whenever I want this. So this is a function called multiplot. And what it does is it allows you to lay out, using sort of a matrix of numbers, how you want things to be. So in this case, I'm going to define a layout where I'm going to define my resulting figure where it has essentially 3 sort of pseudo columns. Now, in column 1, I want to have this graph number 1. In columns 2, 3, and rows 1 and 2, we're going to have figure 2. And then figure 3 is going to be this long and skinny, or long and narrow, long and short version of the plot for plot number 3. So now I'm also going to take plot 2, 3, and 4, and I'm going to put this one in this sort of left-hand 2 rows. The next figure gets these 4 spots, and thus it's twice as wide as this plot. And this plot right here is only 1 unit high, but 3 across. And this gives us complete control over how I want the layout of my graphics to go. Unfortunately, multiplot doesn't have a label option, so if you want to refer to panel A, you've got to insert that into your original plot to begin with. Next, we'll talk about color scales. Generally, if you want to select the colors that your points on a graph make manually, the way to do this is to use this scale color manual or the scale gradient manual. Scale color manual. Now the color part is setting the color attribute of the individual aesthetics on the map. Now sometimes you want to set the fill instead of the color, and there are corresponding versions for fill here. So there could be a scale fill manual or a scale fill gradient as well. So make sure that you're setting the right attribute. Now for the discrete case, and this right here is the example for the discrete case, all we have to do is specify the order of the colors that we want. So right now, the red things are group 1, the navy things are group 2, and the green things are group 3. And this is whatever order your groups are is going to be how this shows up. Now the continuous version of this gives me a color gradient. So in this particular case, I want to be able to say that my girth values start low, and we're going to start with low values being associated with blue and high values being associated with red. So there's a little bit more to there, particularly for the continuous scale, because this continuous scale just starts at one color and then blends into another color. But you might want to have a middle color as well. And so there's also a gradient 2 function, which gives what is typically referred to as a divergent scale, where you set the low and high as well as the midpoint and where that midpoint is. And so for this color gradient 2, I'm going to set the low color to be black, the middle color to be white, the midpoint for what constitutes what should be in that white value is going to be 14, and then what the high value is. And so this gives me this color scale, and I have the ability to move sort of this white point to any place that I want. And so the scale color gradient 2 is pretty flexible. Likewise, there's also a fill gradient as well. Now, we could add more colors to this gradient, and that's what this scale color gradient in does, is it allows you to specify as many colors as you want. And so I could specify, here I did colors of the rainbow going red, orange, yellow, green, blue, violet, and this works. Now, I think this is a bad idea. I think this is a pretty horrible idea because this scale doesn't work, but at the very least, you have the ability to make poor life choices for yourself. So instead of picking a color scale that I like, I generally prefer to pick ones that other people have really thought about, because there are people out there that really have thought about what it means to pick a color palette that works for as many people as possible, because color blindness is an issue. And so I tend to prefer to select a palette that someone else who knows a lot more about colors than I do has already chosen. So there's a couple of ways to do this. In particular, there's a R package called R Color Brewer, and there's ggplot functions that'll do this. So here we have a ggplot scale, then some stuff. This could be fill, this could be color, this could be some attribute that you care about, and this brewer function where we can specify the palettes that the color brewer has. Now, the R Color Brewer works really well for categorical variables, and I've listed out a set of different palettes that you could use. So set 3 is this more pastel-y thing, set 1 is pretty vibrant colors, there's some dark colors, accent colors. Anyway, they've gone through and made some choices as to what works well for categorical variables. And notice that if you have 3 variables, right, it's going to start with this set 1 will start with red, then blue, then green, and that tends to work relatively well. There's a few others. We've got this sequential palettes that sort of progress from light to dark. And then we have some color palettes that have a light middle part and sort of start at a strong color, fade to a light, and then go to another strong color. And so these work pretty well as well. Now, these are great for categorical variables, and I like the color brewer, but there's another package that I like even better. Oh, here's some examples of using the brewer examples. Right, so there's another package that I like even better, and that's this Veritas palette. These are color palettes that have been well thought out and maintain contrast for people with a variety of color blindness types. And they also convert well to grayscale. And so when I make a recommendation about color palettes, I like to go with these Veritas color palettes. These are fabulous. You've got a couple of starting places. I particularly like the Plasma, but the Veritas is pretty popular as well. And what we're going to do is we're just going to use this same scale color Veritas, and this is saying use the Veritas package, and the _D or _C, that recognizes whether we're dealing with a continuous variable and I should make a gradient, or if I'm dealing with a discrete variable and I should make discrete values from the color band. So in the discrete case, what it'll do is it'll pick sort of a starting point, the ending point, and then if I've got however many categories in the middle, it'll divvy up this color bar appropriately to get as much distance in the color space between my categories as possible. So in this case, I've got a categorical 3 different variables, and we've chosen this sort of dark blue color somewhere in the middle for the red, and then the yellow. And you can see that the contrast between these colors is really quite good. Now, in the second continuous case, you see we've got this nice color gradient going from the yellow down to the dark blue. Now, sometimes I think the yellow gets washed out, and I'm not thrilled about that, but it is what it is. There are a bunch of other color palette packages, and I gave some list of some of these, and they're really quite good. But that being said, it's quite the rabbit hole to get down into picking exactly the right palette that you like the best. One of the things that I want to be able to do is modify the tick marks on my x-axis and my y-axis. And in ggplot2, these are referred to as the breakpoints and the minor breakpoints. So a breakpoint is one of these strong, solid lines that is either vertical or horizontal that has a label. The minor breaks, so these are minor underscore breaks, these are the points that don't have a label, and these lines are a little bit thinner. And to modify them, all I have to do is use this function scale x and scale y, continuous and discrete, and a few other options as well. So in this case, I've got my x-axis and my y-axis are both continuous variables. In order to modify them, we're going to use this scale x continuous and scale y continuous functions to modify how the behavior of these scales is going to work. So for my x-axis, I want to have breakpoints at 65, 70, 75, and to do that, we're going to generate this sequence from 65 to 90 where we go every 5th step. And this, we're going to set our major breaks using this breaks equals command. If I wanted to set the minor breaks as well, I would use minor underscore breaks and again give it a vector of points. To modify the y-axis, what I decided to do was I wanted to have breakpoints at 30 and 50, but I wanted to relabel them, and you've got this option to relabel those, and these could be any character string or any value that you wanted, just so long as the number of labels matches with the number of breaks that you have. So next we're going to look at how to plot data that has been log transformed in ggplot2 in a manner that makes it very easy for the user to interpret the information without having to do any sort of log or exponentiation in their head. The data set that I've got has a bunch of individuals and their income along with their age. And their income is measured in thousands of dollars here. So the data set that we've got has one individual who's made quite a bit of money. This is almost $580,000. A few people that are making between $200,000 and $400,000. And then the bulk of the people are making, say, $100,000 or less. Now, I want to transform this information because this graph really is being dominated by perhaps 6 individuals, right? Most of the space up here is blank, but there's 6 individuals that are going on. And so what I want to do is I want to take this data and I want to log transform it. Now, one thing that I could do is I could just make a graph where I take my y-axis and I say, oh, you know what? Let's take my y-axis and log base 10 transform income, and I end up with this curve. But the problem with this graph is that no one can interpret what 0 or 1 means. Because in order to interpret this, I have to remember that the inverse of log base 10 is to take 10 to the whatever is on this axis. So this line right here corresponds to 10 to the 1, which is 10. So this is the $10,000 income. 10 to the 2, this is the $100,000 mark. So this is 1,000, 10,000, 100,000, and this 3 up here would be close to a million if there was a 3. So this is relatively difficult to interpret because this scale is not particularly good. So one thing that we could do is we could try to make sure that the tick marks actually work out well. So the way that we're going to do this is the following. We're going to use this, instead of scale y continuous, we're going to use scale y base 10. And notice I haven't done any change in my y variable originally. So this is the raw income that you're plotting, but you're going to modify the scale, and R is going to do what it thinks is the appropriate thing to do if I'm plotting base 10 information. And so now we have this income where this is $1,000, this is $10,000, this is $100,000. Now, unfortunately, the behavior that ggplot does is it always puts the minor tick mark halfway between my major tick marks. And in this case, this is kind of weird because this is not 50, which is sort of what I would think of as the halfway point. Instead, what I want to do is I want to make my minor tick marks sort of have 10 of them in between this 10 and 100. I'd like to have 10 of them between this 1,000 and 10,000. And so the way that we're going to do this is we're going to set my minor breakpoints to be 1 to 10, 10 to 100 by 100. So this is going to go 10, 20, 30, 40, 50. And then 100 to 1,000 by 100. So this will give me 100,000, 200,000, 300,000. And now we end up with this sort of log grid that some people find appealing to emphasize the fact that we're now in this log base 10 scale. And so I can relatively easily tell that this part right here, this is 20, go up one more breakpoint, that's 30, go up one more breakpoint, that's 40. And this, I think, is probably the easier way to read log base 10 scales. And it's relatively easy to do within R. All you have to do is pick the scale that you want to use in log 10, and then if you want to modify the breakpoints, go ahead and modify both the major breakpoints and the minor breakpoints. The overall look of a graph can be modified using what's known in ggplot as themes. So what we're going to do is we're going to start out with this plot right here, and we're going to modify how it looks using these theme options. Now, oftentimes when you modify this theme, you can do a few different things. You can adjust, say, the horizontal or the size. So in this case, I'm going to center my title and I'm going to make it really big. So that's the size equals 25. Another option that you could do is you could change where the legend location is. So these two theme options are things that I often change, but there's a bunch of other things that you could change inside this theme command as well. Now, one of the things that I don't like to do is to go super crazy in tweaking every little aspect. Instead, there are these other themes that are already predefined for you. And so you can take a plot and then just add a theme on top of it. So this theme black and white is a really super common theme that I use to basically set everything to be black and white and easy to print on a printer. Now notice that it didn't change the color of the layers. This only really affects the background and the break marks and that sort of stuff. It doesn't really affect the plot itself. It affects the background. And we've got a couple themes here that are kind of interesting. We've got a dark theme, we've got a minimal theme, and a light theme. And you can see there are subtle differences in terms of, do we include the bounding box? Do we have a dark background? Do we have a light background? Yeah, there's quite a bit that's going on here. Now, there's a lot of themes out there, and down here I've shown some common ones, although it is a little hard to read, so let's see if I can make this a little bit better. So here's a theme from Cowplot. So these two actually come from Cowplot, and this is the default Cowplot theme that Klaus likes, and this is the minimal where it gets rid of the bounding box. There's some other ones that you can try to imitate other statistical software. So this is trying to imitate STA. This is trying to imitate a theme recommended by Tufte. This is The Economist, where it gets a bigger title and it tries to look like the graphs that you might see in the magazine The Economist. This is trying to imitate what 538 does. If you want to imitate Excel, that's another option. So themes are a really great way to set the tone of a graph, and that can be quite handy. Now, oftentimes we might want to set the theme for the entire document, and this theme set allows me to, for the rest of my R Markdown document, to all of my graphs be set to this black and white theme. And this is fairly common, so that you don't have to, for every single graph, you don't have to set the theme type. I would like to be able to write mathematical notation on my graphs. For example, I might want to write alphas or betas or rows or p-hats or something like that. Maybe subscripts, who knows, but there's often a need to be able to write mathematical expressions on my graphs. Now, R has a notation scheme for writing mathematical notation called an expression. And unfortunately, it is not identical to something called LaTeX, which is really unfortunate, but that's the way that it is. You might remember LaTeX from earlier in the course when we introduced how to write mathematical notation in R Markdown. And I'm going to go back to my R Markdown tricks, my mathematical expressions, and I introduced this idea of LaTeX. And LaTeX has these dollar signs, and everything inside a dollar sign inside the R Markdown file gets interpreted as LaTeX, and it's actually really quite straightforward. So in this case, if I want to do like something raised to a power, I'll use this dollar sign X and then a caret and then a 2, and this will say X raised to the power 2, and this is the output. Now, if I want multiple things in this power, I can just enclose it with these curly brackets, and so this will give me y to the power of 0.95. And these little dollar signs are how we denote I'm in LaTeX mode versus not LaTeX mode. Subscripts are an underscore, so x underscore I gives me I, t underscore, and then these curly brackets give me multiple things. So the curly brackets really are just a grouping character. Gives me t underscore 24. Greek letters are the name of it, just alpha, but preceded by a backslash. Theta is backslash, capital theta gives me the capital theta. There's a bunch of different things in here about how to create mathematical expressions using LaTeX, but LaTeX is sort of the way that mathematicians want to write down their math notations. But unfortunately, R didn't use LaTeX. Instead, they used their own version. So what I'd really like to do is not have to learn how to do things in R's expressions, but rather use the LaTeX that I already know. So what we're going to do is we're going to use a package called LaTeX to expression that will convert character strings written in LaTeX into R's expressions. So what I'm going to be doing is I'm going to be writing LaTeX character strings inside R. But notice that there's this backslash in common LaTeX. But R already thinks that the backslash character already means something special. It means the next thing is going to be interpreted differently than normal. So every time in my LaTeX that I normally have a slash, I'm going to end up with a double slash when I write it in R. Okay, so how we're going to do this is this example down here. So I've made a little data frame, I've fit a model, and now I want to make a graph with some aspect of that model. So what I'm going to do is I want to create an annotation layer where I give the correlation coefficient for my regression. And so what I want is I want to end up putting this rho hat equals 0.96916. So that's what I want to show up here. Now in LaTeX, the way that I would do this is I would have a hat command over a row and give it this number. So this is what I'm going to do. I'm going to go slash slash. That gives me a single slash. And then I'm going to give the row. And then I'm going to feed it into this LaTeX to expression command. And so this is the LaTeX to expression package. The command is text. So this is going to take LaTeX and convert it to expression. And we're going to give this as the label for the annotation layer. Likewise, I'm going to turn the x-axis, y-axis label, and the main title to be these LaTeX expressions. And the only difference between the usual LaTeX expression is that wherever I had a slash, I now have a double slash. But other than that, it's just straight LaTeX. And this is my result. So I can have subscripts in my y-axis label. I've got a Greek letter on my x-axis. And my main title has a whole bunch of mathematical notation in terms of beta hats and transposes and inverses and all that. So this is really, really cool. But oftentimes when I'm making graphs, I would like to have my labels live in a data frame already. And unfortunately, I can't have an expression just live in a data frame. So what we're going to do is this following bit. And we're going to create this little data set called foo. And it's going to have the LaTeX as a string. And then we're going to convert it to sort of R's internal representation. And that's going to be controlled by this output equals character. This is going to be the character string for the expression. And I'm going to jump over to R right now and look at this. So we're going to go and run this command. And then we're going to go and look at this data set foo. So this first one is the character string that is the raw character this is the string representation of the LaTeX that we want to convert into an expression. Now this second label 2, this is R's internal version of what this this mathematical expression ought to look like. And I certainly don't want to remember this. It's much easier to remember the LaTeX. But what we did was in this command right here, I took my LaTeX and I converted it, instead of to an expression, I converted it to the character string that denotes that expression. So if you're going to store an expression inside a character or inside a data frame, you can't actually store it as an expression. You have to store it as the character string representation of it. And then when you go down and actually print it, we've got this label equals the character string representation, and then I have to add this extra parse equals true, and that forces ggplot to look at the character string that you've got and interpret it as if it were an expression and turn it into the correct thing. And then we end up with this graph here that gives me alpha equals 1, alpha equals 2, and alpha equals 3. So the way we're going to deal with mathematical notation is using the package LaTeX to expression. Use the function text to create an expression, but if you need it to be inside of a data frame, use this output equals character, and then it'll save it as a character string, and then you use this parse equals true. One of the more obnoxious parts about RStudio versus some other statistical analysis software is that when I make a graph and I see a data point that's unusual, I would really like to be able to hover over it and get a better sense as to what data point that is, so that I can investigate it and figure out sort of, well, why is this one weird? And so it'd be really nice to be able to hover over a data point and get some information. In other words, it'd be really nice to have a little bit of interactivity with my graph. Now, this actually is relatively easy to get in ggplot2. And the way that we're going to do this is I'm just going to make a regular graph in ggplot. So notice here I've got my trees data set where I've got variables for girth, height, and volume. And we're going to plot volume versus height. So x is going to be the height, y is going to be the volume, and we're going to make a scatter plot. Now, this is our usual ggplot version of making a scatter plot. But all we're going to do is we are going to take this plot, P1, and instead of plotting it usually, we're going to use this new function called plotly. So plotly is a way of creating online graphics and online plots that are interactive. And there's actually a web server called Plotly, and you can check them out. Their purpose is to provide a HTML way of having interactive graphics. Now, the thing that you might not know is that this viewer window actually is built in HTML. And so every time it displays a plot, it actually has a little web browser built inside that displays the plot. And so this function right here actually creates a HTML interactive version of our ggplot item and displays it. And so this plot, after I use this P1, this plotly command, so this is the package plotly, and the command is ggplotly. So it takes a ggplot object and uses plotly to display it. And it took this, and now I've got some hover information. So as I get near the data point, it'll show me, oh, for this particular object, this has height 72, volume 38.3. There are some other things up here that you can do. So you can select various data points. You can do a lasso or a box. You can zoom in. You can pan out. You can save this as some sort of document or a PNG. Now, a lot of times these sorts of graphs get incorporated into like an online news story or something like that, but there's nothing that says that we can't just use this for our own devices. And so this is pretty powerful, actually. Now, right now, all I've got is the height and the volume, which is by default the only thing that we had saved when we did this ggplot thing. Now I'm going to scroll down to a little bit more complicated of a situation, and I'm going to add another aesthetic. And what I'm going to add is I'm going to add the girth column as well. So I'm going to make this text and this is going to be what gets displayed by the hover text. And I'm going to display this girth, and I'm also going to put it in a new line and display the observation, which is just the row number. So I'm going to take this trees data set and create a new column, which is the observation row. And so if I just run this, we can see that this just grabbed the row number, which is pretty handy. And the hover text is I'm going to augment the volume and height with this girth, a new line, because that's what the \n represents is a new line, and then the observation number. And so I'm going to create this graph and then plot it, but using ggplotly. And now when I hover, I have both the height and the volume, but also the girth and the observation number. So this is a really convenient way to get a little bit of hover text in ggplot pretty easily just by creating your usual ggplot, and then instead of just doing a basic creation command, plot it using ggplotly that comes from the plotly library.